Hi there, and welcome back to the AI Developer Bootcamp. In this module, we're going to be looking at how to use Microsoft's AI platform and the cognitive services to work with natural language. Language is a key part of the Litware Insurance demo. We saw in the last module how to interpret the user's intents, but there are many more components that use natural language processing. So in this module, we're going to look at how we can interact with our users in a variety of different languages, and we're also going to examine how we can understand the sentiment of the messages that our users are expressing. As you might recall, at the very end of the Litware demo, we actually showed how we could detect a negative sentiment and escalate that to a customer service representative. Within the Cognitive Services language family, there are 6 technologies that we're going to look at. We've already taken a look at LUIS, or the Language Understanding Intelligence Service. We're going to look at the remaining 5 in this module. And we're going to start by looking at the Bing Spell Check service. Now, on the surface of it, you might think that the Bing Spell Check service is something that you might use when building a text editor or a document editor, for example. However, the power of Bing Spell Check for the natural language developer is significant because it allows us to not have to worry about all the different ways that users can misspell or misstructure their natural language queries. The Bing Spell Check service can help in a bunch of different ways. It can fix incorrect word breaks, it can identify slang, it can find and correct proper names, it can detect homonyms, and it can also recognize brand names, in addition to standard spell checking functionality. It supports 18 languages, and it allows the natural language developer to ensure that the language that they reason over is correct and not have to build in additional logic to support queries that may contain misspellings. So let's take an example of this. I have a sentence here: "Hello folks, welcome to Florida. Hope you have a great week." There are 2 errors here. One, hope is incorrectly capitalized, and great is misspelt for this particular scenario. So what happens when we post this up to the Bing Spell Check service? It returns 2 corrections, one for the capitalization and one for the incorrect word. In both cases, it gives us a probability back, so we can make a decision in our application whether to accept or reject the recommendation that the Spellcheck API has provided us. Now, you might be recalling the last module when we looked at LUIS and thinking, gosh, that would be a really great addition to my LUIS pipeline. If you're familiar with search engines like Bing or Google, you would have become accustomed to being able to spell words basically however you might like to, and the engine still recognizing your intent correctly. LUIS is just the same, and in fact has built-in connections to the Bing Spellcheck API. So for example, if I sent a query to LUIS that was "tell me a joke," and I missed the O out of joke as I have here, it may still match that using its model, but it's likely to be a very low quality match, and it may mismatch it depending on the complexity. If we enable the Bing Spellcheck API, then it will pass this user phrase to the API first, accept the changes that the API recommends, and then run it against the model. And in this case, you'll see that the match is of a much more confident level. All you need to do to enable this functionality is check one box as you're publishing your model in the LUIS portal. And it's highly recommended to improve the experience for your users. So that's the Bing Spellcheck API. It's an incredibly valuable addition to any natural language pipeline. The next service that we're going to be talking about is Text Analytics. And this service is what helps us identify in the Litware demo when users are getting irritated with the bot or might need a customer service representative. The text analytics service is very simple to work with. It allows you to do three things. It allows you to post up a message of text and it will tell you which language that message is in. It allows you to do sentiment analysis. You can post up a message and it will give you a number back between 0, which is very negative, and 1, which is very positive. And then finally, it can do key phrase extraction. So if you send up a paragraph, it can pull out the key topics within that message. You can submit up to 1,000 1KB documents in a single request to any of these APIs. And it's already pre-integrated into a number of different solutions from Microsoft, including Data Lake, Power BI, and even non-Windows SDKs like Android. One thing to watch out for though with the Text Analytics API is that the billing model is a little bit different to many of the other cognitive services, which are strictly pay-as-you-go. In this case, you have to pay an upfront fee of $75 a month, and that covers 25,000 transactions. However, if you're only using it for a quick demo or a quick exploration, that might be a slight surprise on your bill at the end of the month. So let's have a look at what the API can do for us via an example. So we have a custom text phrase here. I had a wonderful experience, the rooms were wonderful, and the staff were helpful. Let's pass this to the three APIs that the Text Analytics service exposes and see what the results are. So the first one is language detection. It can correctly and easily identify this as English with a high level of confidence. Next, we do sentiment analysis, and we can detect that it is highly positive, just short of a 1.0 perfect score. And then finally, if we pass it through key phrase extraction, we can pull out phrases like wonderful experience, staff, and rooms. So running large quantities of text through this API can allow you to quickly gain insight into its content. Consider, for example, customer feedback. You can quickly identify whether it's negative and potentially requires additional attention, and then aggregate this data through key topic analysis to identify key themes and trends. And that's what we saw in the Power BI dashboard in the Litware demo. So that's Text Analytics. The next service that we're going to talk about, and we saw in the Litware demo, was Translator Text. This is what enables multilingual interactions with our bot. This service supports over 60 languages and already powers some of Microsoft's biggest name services, including Office, Yammer, Bing, Skype, and many more. It allows us to submit a message in one language and receive a translated version in a specified other language. One thing to watch out for here is that this is the only cognitive service that has a traditional XML-based API. It's still a RESTful service, but you will need to work with XML to post messages to it. One of the most important things to be aware of when working with the translator service is the importance of context. The bigger the sample of text that you can provide, the better the translation is likely to be, because it has additional context to understand the meaning that the user is trying to express. So for example, in our Litware demo, if you simply wanted to translate the word sedan, then that may not result in the translation you expect. In fact, if you did a language detection on that particular word, I think you get back Swedish. However, if you send through I need insurance, even though that's a relatively short sentence, you'll get a much higher quality and confident translation. So when we're dealing with this kind of natural language translation, we're much better off when we can get the user to express sentences rather than individual words. When it comes to text translation, there are two major approaches available. One is statistical machine translation, and this has been the basis of language translation for many years. But for folks that have been using translation services for many years, you'll recognize that it has some inherent limitations. The other way of taking language and translating it is to use deep neural networks. And this has fundamentally shifted the level of quality that we see in language translation models. I've got an example here of a Korean message about a piece of equipment. And I'm going to run it through both a statistical machine translation model and a deep neural network. And both of these models are currently in production in the Translator API. So you can replicate this yourself. You'll see the general or the statistical machine translation based model is barely comprehensible, as opposed to the neural network based model, which is much cleaner. The reason I show you both of these models is that they're both available to you as a developer. You need to specify the model that works best for you. So you should evaluate both and then choose the one that works best for your scenarios. But as you can see, the potential of neural network-based models is huge, especially for a number of the East Asian languages. One thing that I will point out though, is that depending on the language that you need to translate with, you may be forced to use statistical machine translation. It has a much broader set of supported languages at this point in time, given that the neural network-based models are relatively new. So if we compare the performance of the Translator API to human translators, they're still, to be honest, not as good. The quality can be described up to good and is sometimes mediocre. However, when compared to humans in terms of scalability, turnaround time, and cost, the API wins every time and can unlock a range of interesting scenarios for your organizations. So that's the Translator API. That's how we were able to unlock multilingual conversations in our Litware Insurance bot. The next couple of services that I'm going to talk to you about are probably more in the advanced category for dealing with natural language. It may not be as applicable as the services that we've talked about thus far. The first is the Web Language Model. This is trained on Bing web search data to understand language and helps us accomplish some common natural language tasks. Right now, unlike many of the other services, this is only available in English. It allows us to do 4 things that are common tasks when we're working with natural language. First, it allows us to do word breaking, so we can break URL strings up or hashtags. It allows us to do probabilities. So for example, understand which words are most likely to come next, or which words are likely to appear together, which helps us understand and correct natural language samples. The other advanced service is linguistic analysis, and this, like the Web Language Model, is only available in English as well. It allows us to take a body of text, a paragraph or more, split it out, tokenize it, and then identify the individual parts of speech. And as you can see from this diagram, it helps you identify how the sentences are structured and the purposes of each word. This is an incredibly powerful tool. However, the obligation is on your application to then process this result and understand what it means from a natural language perspective. So while it's a powerful tool, you shouldn't be underestimating the work that's required to actually act on the data that it returns. Before we jump into the demo, let's take a look at how to get started with the cognitive services. The first thing to recognize is that cognitive services have a defined life cycle. They start in the lab stage, then they go into a preview that's available through Azure, and then finally they become generally available. In the lab stage, they're typically only available through a dedicated portal that the team themselves maintain. It's only available typically in one region, and there's no SLA or requirement to pay. Then the service will move into an Azure-based preview. There'll be paid tiers available, there may be an SLA, but it's probably going to remain as a single region service only. And then finally, they move into GA. There's a full SLA, they're available in numerous Azure regions, and they have the full support offered by Microsoft. To get started with these services depends on where they are in their life cycle. If they're in the lab stage, you'll need to go to the product-specific portal. If they're in the Azure Preview stage or the Azure GA stage, you'll need to go to Azure to sign up for a key. An alternative approach to that is to go to the Try Cognitive Services website. On the Cognitive Services homepage for Azure, you can click Try and actually get short, time-limited keys to start playing with without having to go through the Azure portal. Right, with that said, let's jump in and have a look at how we can use Translator and text analytics in our bot. So before we go and show you how to use text analytics and Translator in your bot, we're first going to go to the Azure portal and show you how easy it is to provision these services. So to create one of these cognitive services, all I need to do is click New and search for the service. So in this case, text analytics. I select the result here, click Create, and I have to specify only a couple of properties. I have to give it a name, a location, and select the pricing tier. And that is all that's required. Now, once it's provisioned, we can actually open up the service, and they're all basically exactly the same. They all look exactly the same. You have an option to scale up and down based on your budget, and there's a list here for keys, right? So you can get a primary and a secondary key, and that's the key that you're going to need to call the RESTful API or use the SDK. So with that done, let's go and have a look at how we can use text analytics in our application. Now, if you think back to the Litware demo that we saw in the first module, we used text analytics to determine when the user was getting frustrated and we needed to escalate that to a customer service representative. Fortunately for text analytics, there is actually an SDK, so it's relatively straightforward to get started. So let's have a look at what's required to go in and get sentiment for a message that the user sends. To set up the SDK, we just specify the region where our particular instance of the text sentiment API is hosted, and we specify the subscription key from the Azure portal. Then we have to actually make two API requests. One of the things about the sentiment API is that it requires the language that the user is using. Now, in this particular scenario, we allow our users to speak a number of different languages. Our bot is designed to support multilingual interaction. So the first thing we do is post that message that the user just sent up to the language detection API. Once we have a language in place, we can pass that language and the original text to the sentiment API. And we get back a value between 0 and 1, where 0 is very negative and 1 is very positive. Now, it's a little bit unusual how we have to interact with the API here, because the API is designed to support up to 1,000 1 kilobyte documents in a single request. So we actually have to build this small batch of a single record and post that up. So when you work with the SDK, keep an eye out for that. It's not designed simply for a single record. So we've got the text sentiment service now implemented. How are we going to integrate this into our dialogue? Let's take a look. What we want out of this particular part of the interaction with a customer is a decision on whether to escalate or not. It's a Boolean. We'll put it on a class, and we're going to use this class with the Form Builder SDK to build an interface. Now, obviously, we don't want the customer to have to answer escalate yes or no. We're going to use their sentiment to make that decision. And we can do that by overriding how the bot service exposes this particular question. So we're going to override the prompt, and we're going to say, what do you think? If this sounds good, we can start your coverage right now, to allow the user to respond. And we're actually going to override how we recognize the user's response. Because this is a Boolean field, typically we would get a yes or a no restriction around it. However, because we've overridden the recognizer, we can actually now accept any kind of string content successfully. Once we receive that string content, we can actually process that in the validation method. We can take the content, we can post it to the text sentiment service and get back a result. We can then map that through to a Boolean that we return, and that will then get mapped back to the underlying class. We also define an onCompletion handler. So once this flow is complete, depending on whether it's escalated or not, we can take an action. And in this scaled down version of the Litware bot, we just send an appropriate message back to the user. So let's take a look at this. The last thing that we'll have to do is actually wire this up to our chain. So the first one in the chain is going to be which type of insurance. The next item in the chain is going to be what kind of car. And the third item in the chain is going to be an offer and a detection of sentiment to determine whether we need to engage a human agent or not. So let's start this up and see what experience we get. Now, once the emulator is running, we're going to restart. And I'm going to say, I need car insurance. So this will actually skip the carousel, save us a little bit of time. I'm going to say it's a sedan. And then I'm going to specify all of the information needed. Ford Fusion 2011. I'm not going to separate that out. There's a little bit of sneaky logic in there to skip the remaining steps if we provide it all in the first answer. So now it's coming back and says we're going to offer you a rate of $116 per month, and we get to respond to that. We're going to say the classic response that we used in the first demo, no, that's way too expensive. Now, we've put a breakpoint in the code. We can see that that information, that message has been passed to the text sentiment service, and we get back a value. And in fact, in this case, we get back a value of 0.0005. So this is an extremely negative response. So in this case, it's entirely appropriate to escalate to a customer service agent. So we'll continue through this, and we can see in the emulator that the right message is returned, and it says that it's going to go and pull in a customer service agent to help salvage this deal. So that's how we can use the Text Analytics API in an interactive, near real-time scenario with a bot. One of the other really cool ways of using the Text Analytics API, and actually a number of other cognitive services, is through Data Lake, Microsoft's petabyte scale data storage and analytics platform. So let's go and have a look at that in action. So if we bring up Data Lake Analytics, we can review a job that I executed yesterday. The job involved taking the entire text of War and Peace and running each paragraph in each book through the Text Analytics API. And using that Text Analytics API to call out what the sentiment of each paragraph was and what the key topics were. So while this is a fictional example, you can imagine doing something very similar with aggregated customer feedback, messages or tweets. So let's go and have a look at the outcome here. Here's the job I ran yesterday called Text Analytics. This does require you to install some extensions into your environment so the cognitive services become available to you. We can have a look at the script. The script is written in a language called USQL, which is the native way of writing queries against big data in Data Lake. It's very similar to SQL, so if you are familiar with SQL, then you can probably guess what's happening. So what I've done here is I've extracted this data from War and Peace. War and Peace is currently as a CSV. I'm extracting the book, the chapter, and the text that I want to analyze using a CSV extractor. And then I'm passing each record through the key phrase extractor, which is the Text Analytics API underneath, and also the sentiment analyzer, which is the sentiment analysis API that we just finished using. And then once that's done, we output the results to two other CSV files. So we can check out the results. We can open up, for example, the sentiment results. So this shows for every single paragraph in War and Peace, the sentiment of that paragraph. So for example, we have one here, which is one of the earliest paragraphs in the book, which references war, horrors, and even the Antichrist. And this is marked as an extremely negative sentiment, unsurprisingly. So if we were to replace War and Peace with customer feedback that your social media team, for example, had received, we could easily go through and fish out any of the really negative messages and address them for further investigation. So that's the power of the Text Analytics API. The other API we've been talking about is the Text Translator API. Let's take a look at how we can integrate that into our bot. So working with the translator service is actually relatively easy. The only gotcha to keep an eye out for is that it does use XML. So if you're expecting JSON, then you're going to have to change your code to be able to parse XML out. The other thing to keep an eye out for is how you authenticate with this particular service. It's not as simple as simply taking the token from the Azure portal and inserting it into the message that you send. Instead, we take the token and we pass it to this issue token 10 endpoint. And this returns us a time-limited JWT, which we use to authenticate with the actual translator service. Now, this token is valid for around about 10 minutes, so we can actually safely cache this in memory for subsequent requests and then expire it as appropriate. And this particular variation on authentication is used by a couple of the other cognitive services as well. So we post up the token we get from the Azure endpoint service to this particular endpoint, and we get a JWT back that we can use to call the actual translator service. So we can add that into the header as a bearer token once we've fetched it. And then we can simply post the content that we want to translate as parameters in the URL. We can specify the from language and the to language and let the API take care of the rest. Now you'll notice there are two methods here. One is the detection API and the other one is the translation API. The translation API does require you to specify which language you want to translate from. So that's why we have a detect step here. It's also useful when we start to use smaller phrases to be able to explicitly specify which language the user is speaking to avoid any potential mistranslations. So now that we have the translator service wired up and the authentication sorted, the next thing to do is to translate incoming messages. So when we receive a message from the user, and the easiest place to do that here is just as the message is deserialized, we can translate that. And then the LUIS functionality will run on the translated text rather than the original. So what we're going to do here is the first phrase that the user speaks, we're going to detect its language, and then we're going to use that same language for the remainder of the bot conversation. Let's kick this off and see how it works. And I'm going to copy the French translation that I have for I need insurance. Let's return to the emulator. We'll refresh this, and then we'll paste in the French inquiry. This gets sent to the detect API, it gets detected as French language, it gets translated to English, and then passed to LUIS for analysis. Now, interestingly, the bot has responded in English. And that's to be expected because we've only translated incoming messages and not outgoing messages. Now, if you have full control over your dialogues, that is that you don't use LUIS, you don't use the form builder, then it's actually quite easy to translate the outgoing message before your code completes executing. However, if you're using one of the framework support pieces, like the form builder, then a little bit more work is required because you need to plug that translation into the form flow. The easiest way to do that we've found is to use a custom prompter. So when you define your form, you can actually override a property called prompter. So we're going to do that when prompting for the type of insurance. And I'll show you the custom prompter that we've built. Custom prompters allow you to completely and utterly customize every aspect of how your forms get rendered. So if you want to change from carousel to list or to separate messages into multiple messages, or style or format, or potentially even add text to speech attachments, this is the place to do it. So if we detect the language is not English, then we're going to translate. And keep in mind, it's not just as simple as translating the message that is being sent back, because there could be a lot more to the message. If we're sending back a carousel, then we need to translate all of the buttons, we need to translate all of the labels on those hero cards as well. So we may end up having to call the Translate API a few times here. So now that we have defined our custom prompter and attached it to our form flow, let's try that exact same phrase again. We will reconnect to the bot once it starts up. We're going to paste in our French snippet. It's going to detect that as French. It's going to translate that to English, pass it to Lewis. Our form flow will respond to it, and then we're going to retranslate all of the content that we want to send back. So we get French versions of all of the buttons and all of the questions about whether the insurance type that we're interested in. And that brings us to the end of this particular example. Let's get back to the slides. So we've just seen how we can use the translator service to be able to accept messages into our bot in other languages and then have our bot respond in that language. We also saw how we could use text analytics to detect user sentiment and escalate as appropriate. So let's wrap up our session on language with a bit of a summary on when to use which of these technologies. The easiest technologies to get started with are text analytics, translator, and Bing spell check. They will all provide an immediate return to your application. Text analytics is literally as simple as posting up text and getting answers about its sentiment and topics. Similarly, translator only requires you to post up text and the destination language. The next step when looking at natural language technologies is Lewis. Now, Lewis is a little bit more complex because you need to provide your own data to train it. The training process itself is simple, but you do need to collect the data and provide it to Lewis before you can start interacting with the service. And then finally, the advanced options, the web language model and linguistic analysis. As discussed, they're English only. They do provide advanced natural language capabilities, but will require a similarly advanced natural language pipeline or application to take advantage of them. That brings us to the end of our session on language and the cognitive services. To wrap up, we were able to answer two of these questions that we posed at the start. We saw how we can use the text translator to interact with users in other languages. We also saw how we can interpret the sentiment of our users' messages using the text analytics service. I hope you'll join us for the next session in the AI Developer Bootcamp when we look at the knowledge and search capabilities in Microsoft's AI platform.